Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Pramudito Bagas Umboro. In this video, I will be explaining my answers to the final exam that was given to us from Mr. Dai. There will be a self-evaluation using the Die 5 to finish a problem, and also my comment on Elon Musk's question to AGI. So first, I will have a self-evaluation regarding my studies throughout the second half of this semester in numerical methods. So, throughout my studies, I have learned more and more about myself, my strengths, my weaknesses, and my limits. In the second half of my fourth semester, I am studying new materials, including numerical methods. In numerical methods, me and my classmates were given the Die 5 concept as a framework for our thinking process. This new concept has exposed me to understanding myself more. Using the Die 5 method, I have subjected myself to organizing my thought process before confronting a problem. I have made 11 videos for this and 10 of them uses Die 5. Throughout making those videos, I have come to the understanding that I can easily set a goal in my mind and follow through. I have managed to help simulate a flow through a channel using CFD-Soft and represented it to my peers, helped a friend make a video on its tutorial, made a video explaining circular economy in Singapore's waste and management system, and more. I have proven to myself that I can stay conscious when needed and execute tasks. However, I have learned and confirmed multiple flaws within myself. The main flaw is time management, where I struggle to keep a deadline I set for myself when finishing a task. Though with this flaw, I still manage to get through. From my performance, I have hope that I can get a score of around 78 to 85. Next, I will be explaining how to solve a problem using Die 5. The problem will be finding the suspension system for an STT or a military trailer that will be carrying a satellite. So the first step is my consciousness. In this step, we focus our full attention on the problem at hand. We ensure that we understand the requirements, constraints, and the significance of solving these problems accurately. Step 2 is intention. Our intention is to solve these problems using numerical methods and analyze the results to determine the best engineering solution. We will employ tools like differential equations, numerical solvers, and graphical analysis. And our intention is also to use our knowledge gifted to us by God to optimize the suspension system on an STT trailer and also to ensure minimum to no damage suffered by the STT when being towed to an active operation site. The next step is initial thinking. On the first problem, we need to model the suspension system of an STT trailer loaded with a satellite and analyze the critically damped value for different shocks. And for the second problem, we will model the force on the shocks due to severe terrain and determine the displacement of the suspension system over time. On the third problem, we analyze undamped shocks for the STT suspension system and explore how varying the frequency of external forces affects the system. And on the fourth problem, we model the vertical motion caused by a high-powered machine gun mounted on the trailer and estimate the damping coefficient. And on the fifth problem, we simulate the STT suspension system, reversing rugged terrain modeled by impulse forces. And the next step is idealization. In the first problem, we calculate critically damped value by inputting the mass m and spring constant k. And then we compute critical damping coefficient using the critical damping equation and then compare the given damping coefficient. After that, we formulate differential equation by defining mx plus beta x plus kx equals 0 with the initial conditions of function x to 0 equals 0 and x dot of 0 to equals to 0. And then we solve the differential equation. We find the beta and then beta critical and then using numerical methods ODINT in Python. And then after that, we plot the solutions. We plot the displacement for x to t for both beta and beta critical. For the second problem, we model external force by defining function t equals to 200 sin for t. And then we formulate differential equation by defining m x double dot plus beta x dot plus kx plus equals to function of t with the initial conditions of x0 equals to 0 and x dot 0 equals to 0. Then we solve differential equation using numerical methods ODInt in Python, and then plot the solution of the displacement xt. And then we analyze the performance by and calculate the maximum and minimum displacement. And for the third problem, first we must model variable frequency force by defining f, the function of t, equals to 200 sin for omega t. And then we formulate differential equation by defining m x double dot plus kx equals the function of t. And then initial conditions of x0 equals 0 and x dot 0 equals 0. And then we solve differential equation for different omegas using numerical methods ODInt in Python. And then we plot the solutions of xt for different omegas. And then we analyze frequency effects. And then we identify the frequencies causing excessive oscillations. And for the fourth problem, we plot displacement data, input displacement data from measurements, estimate damping coefficient by fitting model to data, and minimize sum of squared errors to estimate beta. Then we formulate differential equations by defining mx double dot plus beta x dot plus kx equals to the function of t with initial conditions x0 equals to 0 and x dot 0 equals to 0. And then we solve the differential equation using numerical methods by using ODInt in Python and analyze the frequency components if there are resonance or beats that are present. And then for the fifth problem, we model the force with impulse functions by defining function t equals to omega 0 sigma n equals 1 to n times of sigma times t minus open bracket 2n minus 1 close bracket times pi. And then we formulate initial value problem by defining m x double dot plus beta x dot plus kx equals function of t with initial conditions of x0 equals to 0 and x dot 0 equals to 0. And then we solve the IVP using Laplace transforms by applying Laplace transform methods. And then we verify and plot the solution using Mathematica to verify and plot. And then we analyze the performance by calculating the maximum and minimum displacement and provide recommendations for safe traversal. And then we have the final step, which is instruction. For the first problem, we calculate critically damped value using this code, and then we formulate and solve differential equation using this code. And then we finally plot the solutions using this code. Keep in mind, these are all pseudocodes, which are not actually Python or C++ languages or any of the codes languages. And then for the second problem, we model external force using this code and then solve differential equation using this. And then we plot and analyze solutions with these codes. And then for the third problem, we model variable frequency force using these codes. And then we solve differential equation, analyze frequency effects. And then for the fourth problem, we plot the displacement data first. And then we estimate damping coefficient. And then we formulate and solve differential equation. And then we analyze frequency components. And then for the fifth problem, we model the force with impulse functions. And then we solve IVP using Laplace transforms. And then we verify and plot solution. After that, we analyze the performance. By following these steps systematically, we can solve each problem effectively. This structured approach helps ensure accuracy and clarity in our analysis, ultimately leading to better engineering solutions. And then for the B question, which is my comment on Elon Musk's question for AGI. For this comment, Elon Musk wants to ask the AGI what is outside of the simulation. From my discussion in class, it is believed that Elon Musk is asking the AGI what is outside its understanding or its simulation. However, when my classmate Torik said that Elon Musk believes that life is a simulation, I can only see his question referring to that. The clip that was sent is only around 1 minute long and is missing a lot of context. And we cannot determine whether he is talking about the AGI or life. However, if Musk asks that question to the AGI, it will likely cannot give a precise answer due to it being programmed with scientific knowledge and cannot feel, be a state of being, and have consciousness. This is what differentiates us from AGI. our consciousness and our ability to think with our feelings as well. We must keep thinking consciously and keep understanding our feelings to not lose to AI. It is the fundamental pillar that keeps us human. And so we must stay conscious, not lose our emotions and feelings, and keep having faith in God that we are living lives with meaning and not just a simulation. Stay conscious. That is all from me. Thank you for watching. I apologize for any mistakes I have said or made. Wassalamualaikum warahmatullahi wabarakatuh.